So let us do this problem number 6. Here a box-shaped vessel is 20 meter. This is a 20 meter into 4 meter into 2 meter. This is the dimension of box-shaped vessel and has a mean draft of 1.05. Has a mean draft of 1.05 meter in salt water. So the box-shaped vessel is floating like this, and this is the draft as 1.05 meter, and the box-shaped vessel is in salt water. Calculate her draft in dock water of RD 1.012. So dock water RD is 1.012. We need to calculate draft in this dock water. Well, we know that the density is equal to mass over volume. So the mass is equal to volume into density. So instead of mass, I can use the displacement is equal to underwater volume, and instead of density I can take relative density. So in case of salt water, the displacement is underwater volume, and in salt water the underwater volume is this one, which is 20 meter into 4 meter into 1.05. Well, this is the volume, 20 meter this side, 4 meter this side, and the draft is 1.05 multiplied by relative density, and we know the relative density of salt water is 1.025, and we get in tons. Similarly, if the vessel is in dock water, let me use another color. So if the vessel is in dock water, say, so displacement dock water is going to be 1.012 is equal to displacement in dock water, which is length. Okay, let me just go back here. The length is 20 meter, breadth is same 4 meter, and the draft, say, let us assume that draft is somewhere here or somewhere here, we don't know. So say somewhere here, say draft is x meter. So I write here as x meter into the relative densities. This is the volume, length, breadth, and draft into 1.012 ton. Well, the displacement in salt water is equal to displacement in dock water. We didn't load anything, we didn't discharge anything, so displacement is going to remain same. Or simply we can write like this, 20 into 4 into 1.05 into 1.025 is equal to 20 into 4 into x into 1.012. So all we have to do, just cancel this. So what we get is 1.05 multiplied by 1.025 is equal to x into 1.012. Or we can find the value of x into 1.012 is equal to, I'm just reversing the equation, I'm bringing the left hand to the right hand side, and this one I write like this, 1.05 into 1.025, or simply x is equal to 1.05 into 1.025 divided by 1.012. So this is the density of salt water, and this is the density of dock water, and this is the draft. So I get the result as 1.063 meter. Well, you can also punch it in your calci and you will get this up to 3 places, 1.063 meter. This is the draft. and we can say that this draft is going to be more. It was 1.05 in salt water. Now the draft is 1.063, which is much more than 1.05. Now let's do this problem number 7. A box-shaped vessel is 18 into 5 into 2 meter. So this is 18 meter into 5 meter into 2 meter in dock water of RD1. So you are in dock water and RD is given, which is 1. At a draft of 1.4 meter, well, the draft is 1.4 meter. Calculate her percentage reserve buoyancy. We need to find how much is the reserve buoyancy in percentage when floating in salt water. So here the vessel is floating in dock water and the RD is taken 1. So this is the underwater volume. So let us find the displacement in dock water, which is going to be underwater volume into relative density. Well, the underwater volume is 18, this length, into 5, the breadth LB, into D, the draft is 1.4 meter, and the relative density is 1, and this is in ton. Now if the same vessel goes to salt water, what happens? Well, if it is in salt water, what will happen? So we can find displacement in salt water is again underwater volume, and let me define this underwater volume as 18 into 5 into x. X is the draft, and into salt water density, which is 1.025 ton. Well, the vessel was in dock water and now it goes to salt water. Salt water is much heavier, which will support the vessel, so the draft will be less than 1.4 meter, somewhere here. Okay, so we can figure it out here. Like, let's do this. 18 into 5 into x into 1.025. Well, this is saltwater displacement here, is equal to dock water displacement, which is 18 into 5 into 1.4 into 1. Now if we see, these cancel each other and I simply get x into 1.025 is equal to 1.4, or x is equal to 1.4 divided by 1.025, and after punching in the calculator and rounding off, I get 1.3658. Well, just I need to concentrate on these 3 digits, so I can write like this: 1.366 meter. That is the draft. Well, in dock water the draft was 1.4 here, 1.4, but in salt water the draft is only this one, which is 1.366 meter. We need to now calculate what is reserve buoyancy. So first let us find total volume, and then we'll calculate what is above water volume. So reserve buoyancy in percentage is given by above water volume divided by total volume into 100. Since this is a box shaped vessel, so life is much easier. If we see, this is 2 meter and here the draft is 1.366. so what is this above water volume? Well, this distance is going to be 2 minus 1.366. so I can simply write above water volume is length, which was let me just scroll it up. The length was 18 meter, breadth was 5 meter. So 18 meter into 5 meter into length, breadth and this height. Well, the shape is like this: 18 meter this side, 5 meter this side, and this upper portion is 2 meter minus 1.366 meter divided by total volume, and the total volume is 18 into 5 into 2, and this one is 100. Well, all we can do is just cancel this figure and this figure, and here we get 2 minus 1.366, so which is give me 0.634 divided by 2 multiplied by 100, or simply I will get 31.7%. that is the reserve buoyancy of this box shape vessel. Now let us do this problem number 8, where the displacement in salt water of a vessel is 3000 ton and the draft is 5 meter. So draft of the vessel is 5 meter and the hydrostatic particular of the ship indicates that her displacement in salt water is at a draft 5 meter is 3000 ton. We need to find the displacement in dock water of RD 1.018 while floating at the same draft, while floating at 5 meter draft. Well, we know that if the displacement is equal to underwater volume into relative density, so that means underwater volume is displacement divided by relative density. So in this case the draft is 5 meter and the displacement in salt water is 3000 ton. So let us find out what is underwater volume in salt water is equal to displacement in salt water divided by salt water relative density, which is 1.025. so displacement in salt water is given, which is 3000 ton. So I keep it 3000 ton divided by 1.025, and that I can write in cubic meter. No need to do anything. Now I have the same draft of 5 meter in dock water. That means underwater volume in dock water is also same because the draft is same. If the draft is same, underwater volume is same. So the displacement in dock water of 1018 is going to be underwater volume multiplied by relative density, which is 1.018, and this underwater volume is same, which is 3000 ton divided by 1.025, so that is in cubic meter multiplied by 1.018. now all I have to do, just punch in the calci and I get this value 2979.512, or simply I will round off 2979.5 ton. Now let's do this problem number 9, that a vessel displaces 4500 ton of fresh water at certain draft. So I can write that the displacement, and which is the fresh water displacement, is 4500 ton. A vessel displaces 4500 ton of fresh water at a certain draft. Find her displacement at the same draft in water of RD 1.020. If you are in this dock water of 1.020, what is going to be the displacement keeping the draft same? So draft is same. Well, this is a very easy problem. We know that the displacement is underwater volume into relative density. So this gives me underwater volume is equal to displacement divided by relative density. Now the displacement in fresh water is given and the RD of fresh water is also given. So we know that underwater volume in fresh water is going to be displacement in fresh water divided by relative density of fresh water, which is 1, and the displacement is 4500 divided by 1. Well, this is underwater volume, so it is going to be cubic meter. Now what is going to be the displacement in dock water of RD 1.020? So similarly, displacement 1.020 is equal to, I'll use the same formula, underwater volume, and well, the draft is same, so underwater volume is also same. So I write like this: 4500 underwater volume multiplied by 1.020. This is the relative density of dock water, and after multiplying I get 4590 ton. Answer. Now let's do this problem number 10. So a ship of 100 meter long and 20 meter wide, so B is equal to 20 meter, block coefficient CB is 0.8, floats in salt water at a mean draft of 8 meter. So draft, and rather mean draft, is 8 meter. Let me mark this way: mean draft is 8 meter. Calculate the difference in displacement when floating at the same draft in fresh water. So we need to first find out what is the displacement in salt water. Well, the displacement in salt water is going to be underwater volume multiplied by relative density of salt water. And the underwater volume, we know that as per the definition, if the length is L and breadth is B and draft is given L, so I just multiply LBD. So 100 into 20 into 8. I multiply L multiplied by B multiplied by D. This is the volume of a rectangular box. So suppose the vessel was like this and it was at this draft. So length, and this is going to be breadth, and this is draft. Well, after multiplying this, all I have to do multiply with the block coefficient, which is 0.8, so I get underwater volume. And this after I multiply with relative density, which is 1.025. So I will get this 13120 ton. That is the displacement in salt water. Similarly, if the vessel is floating at the same draft, so the draft is same, this 8 meter draft is same, and is floating in fresh water. So let me just find out So displacement in fresh water is going to be the underwater volume, which is going to remain same. So let me just do it. 0.8 into 100 into 20 into 8. This is the volume of rectangular box, and we multiply this by block coefficient, so we get underwater volume multiplied by 1, so I get 12800 ton. So the difference is the displacement of salt water minus displacement of fresh water is equal to 13120 minus 12800, so I get 320 ton. Well, if some of you are